Hello, geometry students. Today's learning target is on page 19 of your notes packet, and it's to use inverse trigonometry to find the missing angles in a right triangle. So on page 19, let's take some notes. Inverse trigonometry is used to find angles. And I'm going to show you how to do that on your calculator a little bit later. So sine inverse, so we read this sine inverse. We don't say sine -1. We read that sine inverse is a relationship where you input a ratio, and remember sine is the opposite over the hypotenuse, and that output tells you an angle. The second one, inverse cosine, is a relationship where you enter a ratio, and remember cosine is adjacent over hypotenuse. And the output tells you again an angle. And the third one is inverse tangent or tangent inverse. And it's a relationship again where you enter a ratio. And remember tangent is the opposite over the adjacent. And the output tells you again an angle. So let's look at some calculator examples in pages on this page, numbers 1, 2, and 3. So if you pull up your calculator, if you want to follow along. For the first problem, where it says tangent of A equals 0.75, we're going to press second tangent, and you can see the red highlighted buttons, and then we're going to say 0.75, and we're going to hit enter. And that is the angle A for problem number 1. If I were to do problem number 2, I'm going to go second cosine, and you can see it says cosine inverse, and I'm going to say 0.05, and then hit enter, and that'll tell me angle A, approximately 87 degrees. And for the third one, I'm going to press second sine, so sine inverse, 0.67, and when I press enter, that's going to give me the angle A to be about 42.06 degrees. So before I write that down on your paper, if we read the directions, use inverse trigonometry to find the angle measured to the nearest degree. So for problem number 1, what we typed in our calculator was tangent inverse of 0.75. What we typed in our calculator for problem number 2 was cosine inverse of 0.05. And what we typed in our calculator for problem number 3 was sine inverse of 0.67. And this will give you the angle. So the angle is tangent inverse of 0.75. For number 2, cosine inverse of 0.05. For number 3, sine inverse of 0.67. And let me show you how to do that on your calculator again. So on our calculator, we're going to press second tangent, so inverse tangent, and then 0.75. And because the directions say round to the nearest degree, angle A is around 37 degrees. For the second problem, we're going to press inverse cosine 0.05, so second cosine 0.05, and the angle is around 87 degrees. So angle A is around 87 degrees. And for the third problem, we're going to press inverse sine 0.67, and that angle is around 42 degrees. So this is how we use our calculator to find the angle. In the next couple problems, our goal is to find the measure of angle X. I always like to circle the angle. Then I'm going to label the triangle. So this 24 is the opposite, and the 29 is the hypotenuse, since it's across from the right angle. which trig function has opposite and hypotenuse, that is the sine. So I'm going to say the sine of x is the opposite, 24, over the hypotenuse, 29. At this point, I'm going to pick up my calculator, but before I do that, actually, I'm going to write x is equal to sine inverse of 24 over 29. And this is what I will be typing into my calculator. So on my calculator, I'm going to go inverse sine 24 divided by 29. And that tells me angle x is around 55.85 degrees. The directions say to the nearest degree, so I'm going to say x is around 56 degrees. Make sure you always read the directions. It may say tenths, it may say hundredths. For problem number 2, again, I like to circle the x. The 9 is the adjacent. The 20 is the hypotenuse. So which trig function has adjacent and hypotenuse? That's the cosine. So cosine of x is the adjacent, which is 9, over the hypotenuse, which is 20. Before I pick up my calculator, I'm going to write x is equal to inverse cosine of 9 over 20. Picking my calculator up, inverse cosine 9 divided by 20 gives me the angle is approximately 63 degrees. Since it's set to the nearest degree, around 63 degrees. Let's do the last problem together. Again, I like to circle the angle. The 17 is across, so that is the opposite. The 11 is the adjacent. So which trig function has the opposite and adjacent? That is the tangent. So the tangent of x we know is the opposite over adjacent. So 17 over 11, since 17 is the opposite, 11 is the adjacent. So x is equal to inverse tangent, 17 over 11. Doing that on my calculator, inverse tangent, 17 divided by 11, gives me the angles approximately 57 degrees. So x is approximately 57 degrees. So this was a short little lesson about how to use the calculator to find the missing angle. There is a practice problem on the next page. So let's take a look at those 2 practice problems. My suggestion is you pause the screen and try those 2 problems on your own, and then you come back and check your answer. Okay, let's see how you did. For problem number 1, the equation would have been tangent of x equals 12 over 29. So x is equal to inverse tangent of 12 over 29. And when you type that in your calculator, you get approximately 22.48 degrees. Since the directions didn't say round to the nearest degrees, I went to 2 decimal places. For problem number 2 in the practice, the cosine is the adjacent over the hypotenuse. So cosine x is 8 over 12. So x is equal to inverse cosine 8 over 12. And then using the calculator, I get x is around 48.19 degrees. Again, since the directions did not specify how many decimals, I went to 2 decimal places. And here are the calculator commands that I typed in to get those 2 answers. So I hope you found this video helpful for page 19 and the top of page 20 on inverse trig.